Okay, so in this video, I'm going to teach you how to use RSpec to test in Ruby. Now, this assumes you already have Ruby installed. In order to check that you do, you can just do ruby-v. And if you don't, you can run brew install ruby. However, I won't be doing that because, as you can see, I already have Ruby installed. Otherwise, you won't get a response from this command. Now, if you don't have RSpec yet, you just run gem install RSpec, and that will install it. It was actually already installed for me, so there you go. Now you will be able to use RSpec simply by running the RSpec command. Ta-da! You get your 0 examples, 0 failures, because we haven't written any tests. So, if we want to actually use RSpec to do some testing on our code base, we can actually create and initialize RSpec in our source repository using rspec -- init. Okay, now that has created this little folder here, and in here is where we will create our testing files. So for example's sake, we're using the classic FizzBuzz. So if I go touch spec / FizzBuzz _ spec.ruby, that would be the convention. And obviously, if I'm going to write tests, I'm going to need something to test. So we'll make a library. In the library, we will put fizzbuzz.ruby. Okay. So now we have our file to test and our file within which to write tests, which is fizzbuzz _ spec. Okay. So first, if we're going to test this file, we have to require it. So that's the first line that we put in any testing file in RSpec is we have to actually test. We have to put the link to the other file. So we're going to run that. Okay, it seems fine, otherwise it would throw an error. If this address is wrong, this is how you can check. Oh, you'll get this failure. If you get the wrong path, it will say load error, cannot load such file. And that means you've got the path wrong, but if we get it right, boom, it's fine. And the reason it knows from /fizzbuzz.ruby, the reason it's finding it, even though this is actually technically it should be that is the correct path. So why is this working here? And the reason is it's because of the Ruby conventions that spec and RSpec knows that it's expecting to find the file in lib. So if we rename that like that, I go RSpec, you see it's failed. I haven't changed the path, I haven't really changed. There was no reference to lib in here, but yet, it's still failing. Load error, cannot load such file. So that is why you need to name this lib as according to the proper Ruby conventions. Okay, and now once you've got your two files properly linked, we can start writing some tests. And the first statement that we have in RSpec is the describe statement. And now, what you write in here is not going to provide any functionality in these quotes. This is for your own reference. So you could call it anything, but we're going to describe FizzBuzz. And we write describe do, and within the describe block, we will write our tests. So in this block, we're going to write our tests. So we run that. Still 0 examples, 0 failures, because we haven't actually written any proper tests. So now if we want to, we're going to, for example's sake, for the simplest example, we're going to just test a function. This can be done for classes, it can be done for complex feature tests, or it can be done for small, tiny little unit tests. The possibilities are really endless. So this is FizzBuzz, so in FizzBuzz, it returns the number when given a number that is not divisible by 3 or 5. That's how the rules of FizzBuzz work. Okay, so in here we can write our little expect statement. Now this is within the brackets of the expect statement, we're going to write what we are going to expect to happen. So imagine we've got a function called FizzBuzz and we're going to put in the number 1. So we're expecting to call FizzBuzz with the argument 1. And then we're going to write .to equal, so we're expecting FizzBuzz1 to equal 1. That's what we expect FizzBuzz to do, because that is how FizzBuzz works, my friends. If you give FizzBuzz 1, it should return 1. So now we're going to run RSpec. We've got a failure. Now this is the brilliant thing with RSpec and testing, is it will very clearly tell you what the problem is. So you look at your failures and you go, we've got a useful message here. Fantastic. FizzBuzz returns the number when given a number that's not divisible by 3 or 5. Failure error. Expect FizzBuzz1 to equal 1. No method error. Undefined method FizzBuzz. What do? Well, we have to decode the message undefined method. So it's saying that this method is not defined. Well, why don't we define it? Define FizzBuzz and okay, so we've defined the method. Now it should work. Ooh. Okay, so we've got a new failure, argument error, wrong number of arguments, given 1, expected 0. This doesn't have any arguments, so let's give it an argument. And this is test-driven development, really, I'm practicing here. Oh, okay, so we've run it again. It expected when FizzBuzz, the method FizzBuzz is given the argument 1, we expected it in our test to equal 1. But we got 0, and the reason is because there's nothing in here. So I put 1 in there, boom. Now, one example, 0 failures. That means the test has passed, your test is working. Hallelujah, praise the Lord. There is no problem today, my friends. Our code is working. Yes. However, I'm looking at our function and I'm thinking, ooh, I'm not sure this is going to work. I'm not sure our code is solid, my friends. What do? We write another test. This is test-driven development, my friends. We write the tests and then we write the code. So if you give FizzBuzz 2, you should expect it to equal 2. Now, what did we get? We got another failure. So now you're starting to learn how test-driven development works. First we write a test, and then we run the test, and it goes red, and then you have to fix the problem, then it goes green, and then you refactor, and then you write another test. And this is the TDD cycle. Let's have a look if we can get a nice image of this. Here we are. Here's the TDD cycle, okay? So, you write your test, the test fails, you write the answer, the test passes, then you refactor your code and you write another test and the test fails and the test passes. And this is how you do test-driven development. And this is how you build very thoroughly, rigorously, well-tested code by following test-driven development, which means all your functionality is grown with the tests first. And that allows you to specify very clearly what you expect your code to do. And it also allows you to find more efficient solutions than you may find otherwise. Now, FizzBuzz is a very trivial example. You may think, Tom, I already know how to do FizzBuzz. I know what the answer is. I can see the code in my head already, but it's worth practicing following proper TDD practice. So when you come to a more complex and difficult problem, you will be able to follow the TDD and use it to derive a solution that you may not have found intuitively, following your own whims and ideas about what the solution is. So TDD is a very disciplined and rigorous approach to building code, and it is worth practicing following strict test-driven development. So what's our problem? Well, it expected 2, it got 1. Okay, so when we're doing TDD, we always just read the message, nice and simple. So we jump in here, number. I mean, that's the simplest. So whenever we're doing test-driven development, we always want to do the simplest solution possible. So that is a simple solution. Now, let's write another test. We're always thinking, if we're doing test-driven development, what is the next test that is going to break my code? Now, it should return, is it fizz or buzz? I should really know this. It should return fizz if the number is divisible by 3. Yes, that is how FizzBuzz works, my friends. So we can write another expect statement. You guys have guessed it. Yes, you have. FizzBuzz 3 to equal. And we're expecting it to say fizz. That's what we want. That's the requirements of our code. So we're going to write that. Right, we're expecting now, we've written the code, we're expecting the test now to fail. Bang, it's failed. We expected fizz, we got 3. What's happening? The code's not working. Let's fix it, guys. Okay. Now, so what we can do is number equal to 3, question mark, fizz. So if the number is equal to 3, we will return fizz. It's a ternary operator. So number equal to 3, that will return true or false. That's the question mark. Will the number return? Is the number equal to 3? Hence, if it is, return fizz. Else, return the number. Hallelujah! It works. Fantastic. But how solid is our code? If we put in number 6 there, okay, it's going to fail again. We all know it's going to fail. So now we're going to pop in the simplest solution. Okay, that's passed. What is going on? Because now you're thinking, Tom, you're not writing the proper answer to the code. We know we need to test if the number is divisible by 3. Well, you would be correct. So, in the end, that can be refactored, and that can be, you're never supposed to refactor until you've got the test passing. Now that is another thing with disciplined TDD. You should red, green refactor. So we say, look, it's green, now we refactor. Now we've spotted the pattern. Now we refactor. Okay, and we're going to test again. It's passed, it's good, we've refactored, it's simpler now. Okay, but what if the number is divisible by 5? Then it should return buzz. And by writing out these little tests documented clearly, we can see exactly what we expect our code to do. So we're creating documentation just by doing this process, and we're ensuring that our code does not regress. Later on down the line, we add new features. Let's say we do FizzBuzz BAM. If it's divisible by 8, we might accidentally break our code. And we're adding that new feature. But if we've got these tests, we can always run the tests and make sure that the previous code is still working. So it's equal buzz. So we're expecting FizzBuzz with the parameter of 5 to return buzz. And, you know, Jesus Christ, it's failed. What do? We have to change the code to get it green, my friend. So let's put in another clause here. Number is equal to 5. So number is equal to 5 if number is equal to 5, return buzz. else. Actually, we can just do that. Okay, so we've passed again. Nothing to refactor at the moment, so we write the next test, and now you're really starting to see how it works here. Using RSpec, writing tests. It's rather simple at heart, and that's why it's so good. Okay, so same situation as before, but this time with number 5. Okay, so that's passing. Let's refactor it. Let's make this simpler. So if the number is equal to 5 or a number is equal to 10, that's what this means is OR. That gate, it's an OR gate, a logical operator, return buzz. And we can simplify that simply into modulo 5 is equal to 0. And that's what modulo does, is it basically, you take the number, it divides it by 5 and it spits out the remainder. So 5 modulo 5 is equal to 0, but 6 modulo 5 would be equal to 1, and 7 modulo 5 would be equal to 2, and 12 modulo 5 would be equal to 2. And so that is how we test if this number can be divisible by 5, if number modulo 5 is equal to 0. Okay, so we've refactored, it's green, it's all good. Now we've got one last final situation. It's FizzBuzz. We can just copy this down now. So it returns, let's put a nice little S there. Returns FizzBuzz if the number is divisible by 5 and 3. So a classic example of this is the good old number 15. It's going to fail. It expected FizzBuzz, it got buzz. So we can plop in another one here. If number is equal to 15, return FizzBuzz. Else if, beautiful syntax in Ruby, beautifully elegant syntax, it's gorgeous quite frankly. That's passing, but of course number 30 is going to fail. We know our code is wrong, but we're building it from the ground up with great strong testing. So we're doing it properly. Number is equal to 30. And of course it can seem a bit silly while we're doing it with such simple code, but it really, TDD can really come into its own when you come into a more complex problem. Okay, so yeah, we've got this problem here, same situation, 45, boom, bang. Now the tests are passing and we can see what the solution is. It's when it's divisible by 5 and the number is divisible by 3. There you go. And there we go. We have solved FizzBuzz. Miraculously, we've learned how to write our tests in RSpec. This is how you do it. RSpec init. Gem install RSpec, RSpec init. Create a lib folder with the name lib. Require the name of the file you want to test. Put in a describe block. And that is, so for example, if I was to comment that all out now, and all our tests were to now fail, oh no, I was trying to add a new feature, I made a terrible mistake. We have this very useful structure, and we can see exactly what the test is, what the expected result was, what the failure is, what it actually got, and this makes it very easy to debug our code and ensure that our functionality remains as we go through the continued development of our product. There you go. That's it, guys. If you do have any questions at all, post them in the comments below. Give it a like, give it a share. I hope this has solved a coding problem for you today. Have a wonderful day from Tom.